Good morning, boys and girls. So I have gathered some things here today to do a little bit of a chemical reaction with you and experiment about matter to see the difference between chemical reactions and physical reactions when dealing with matter. At the end of the experiment, at the end of our lesson today, we are going to be able to understand the difference between a physical reaction and a chemical reaction. Now, before we start anything, we have to make sure we have all of our materials necessary. So I have my safety goggles. You remember that when we do anything with reactions and chemical reactions, we want to make sure that we have on our safety goggles to protect our eyes. I have my supplies here. Remember always first to ask for permission from your parents when you're doing anything. Make sure you clean up your messes. It's not their job to clean up your mess. It's your job to clean up your mess. Protect your eyes at all times. This can be a little bit messy, so I have a container to hold my stuff in just in case it oozes out all over the place. I have a graduated cylinder here. I have some hydrogen peroxide that we're going to be using today. I have some dish soap. I have some household yeast, and I have some food coloring. So we are going to do a little bit of a household experiment or a little bit of a chemical reaction, as they say. So first things first, I'm going to put on my safety goggles. I look so spectacular. Always protect your eyes. Safety first. I'm going to put in about 50 milliliters. So I'm going to measure. I'm going to keep it level. And I'm going to look, and I have about 50 milliliters of hydrogen peroxide in. I'm putting my top on tight. Next things, put that off to the side. I'm going to put in some dish soap. It's just Dawn dish soap. Nothing's too fancy about that. You can find that in the house, and it's just going to drop in a few drops. No really measurement needed, just a few drops. So that brings me up to about 55 milliliters. Now I'm going to drop in some food coloring, probably about maybe 10 to 15 drops. I chose two colors today. I chose red and blue because if you remember with Dr. Cherry, when you're mixing colors, red and blue tend to make what color? That's right, they tend to make purple. So here we go. So we're going to just drop in 2, 3, 4, 5, 6, 7, 8. And that one, put the top on that. Remember, be careful with the food coloring because it can stain your fingers. 6, 7 of those. There's 15. Now, here's what we're going to do. I've mixed up 3 tablespoons of hot water or warm water and yeast. I'm going to stand back a little bit, pull this away from my computer so you can see it, and let's see what happens if it's done right. There you go. As you can see, it bubbles up and it's going into my pan so you can see now what's happening. Very cool. It's kind of a pasty foamy type thing, and it's a purple blue thing, and it's foaming up over the top. As it's coming out, you can start to see it makes that foam at the top. And it's called, what we made today, boys and girls, is elephant toothpaste. Now, there's a lot of different ways that you can make elephant toothpaste, and it's going to keep foaming over the top of my little pie tin that I had here. So, made quite a bit today. You can touch it, but I don't recommend touching it. It is all safe. It's not going to hurt you. Remember, when you touch things, keep it away from your face. You don't need to smell. We don't smell things in the science lab. We don't taste things in the science lab. Those are two rules that we've always had that are off limits. If you're going to waft to whiff, remember, smell this way. We have our safety goggles on. But what happened? What is up with our chemical reaction? Okay, it is a foam. What happened? Why did we get this? The yeast acted as a catalyst. There's lots of different things going on in a hydrogen. There are ways that you can see it. If you've ever watched them on YouTube, they have this big explosion. There's a couple different things that they add into. I'm going to move this out of the way here. There's a couple different items that you can add into To get the bigger explosion, to get the bigger reaction, you can add potassium iodide, which I don't have any here in my house. I have that in the science lab, in the STEM lab at school. To get that bigger chemical reaction where it shoots up out and has this huge reaction. I don't have that here at the house. Like I said, that's more of a science or STEM chemistry type of reaction. I don't have that here in my house. You can use a stronger hydrogen peroxide. I used a 6% solution. 3% is what they typically sell in the stores. I happen to have a stronger one here at my house, which they use. Hair salons have it, nail salons have it. I use a stronger one here at the house for personal uses. It's still safe to touch. So it's safer to do at home under parental supervision. If you add more yeast, if you add less yeast, you can get different reactions. If you add more hydrogen peroxide, if you add more soap, all of those you can change into a experiment and see what type of reaction you're going to get. But what caused the chemical reaction? What happened? Well, what happens, boys and girls, is that there's oxygen that gets released and causes those tiny foam bubbles. And as it explodes and expands, that's what releases up out of my graduated cylinder. So the faster the reaction, the more that it gets released. Now, the other thing that happens that is really cool is when you use the potassium iodide, you also can have an exothermic reaction, and that's where heat becomes involved, and it gets hot to touch. This one is not hot at all. There's a little bit of heat, but it's not hot to touch. Right now, it's just like a foamy mess, and what's left is that hydrogen peroxide gets broken down, and that's that bubble and that oxygenation that happens in the oxygenated, and that's why you get the foam. So it is safe to touch, and you're kind of left with like a soapy mess. And you can dump it down the drain with mom and dad's permission and clean everything up. Like I said, it's your responsibility to clean it up, not mom and dad's. But you're left with a soapy mess. So it is safe to clean it up. But it's kind of fun. That's a chemical reaction. Chemical reaction, when you join two things together and you do something chemically to it, I obviously can't take that apart. I can't separate out my soap. I can't separate out the hydrogen peroxide. I can't take back out the food coloring. I can't take back out the yeast. I'm left with nothing that looks like what I started with. That does not look like clear hydrogen peroxide. It does not look like my Blue Dawn dish soap. It does not look like my purple or red and blue food coloring. And it does not look like that nasty brown yeast that I put in there. Like I said, there is some heat to it. I can touch it. It's kind of foamy. It's not hot. Kind of feels like warm soapy water, like what you wash your dishes in maybe. So there's heat involved, that's exothermic. There's a catalyst involved, that's the yeast. Yeast helps raise your bread. That's why your bread gets nice and puffy, and it's not flat bread, it's puffy bread. But that's a chemical reaction. When you have a chemical reaction, boys and girls, you can't put it back to the way it was. Now, a physical reaction is when you still know what it is when you're done. For example, I have a piece of paper here, okay? This is a piece of paper. If I fold it, I'm doing something physical to it. It's still a piece of paper. I just folded it in half. Still a piece of paper. If I rip it, it's not as pretty as it once was, but guess what? I still know it's a piece of paper. Half for you, half for me. But it's still paper. And if I really needed to, I could tape it back together and it would still be a piece of paper. It's just a physical change, not a chemical change, like what we did over here with our experiment. It's still a physical change. Didn't necessarily do anything to it, other than just rip it apart. I physically did something to it. I didn't chemically alter it. Could I chemically alter this piece of paper? Sure, absolutely. I could burn it. I couldn't put the paper back together again. It would be something totally different. It would be a little tiny pile of ash that I couldn't put back together. But physically, I could tear it into little tiny pieces and I could tape them all back together again. But who wants to waste that time? Not me. But chemical changes, they can be fun, they can be entertaining, like the experiment we just did. Now I have an experiment for you to try at home. It's a little bit easier to get our hands on it than all of that other stuff. And it's really cool. Now, I did not go out and buy it. So don't go out and buy if you don't have to. I just happen to have these things that are lying around my house. It doesn't work as well though, however, if you don't have a bottle. So if you happen to go out and have your mom and dad have a bottle of soda and you want to use it, that's great. So here's my experiment for you guys. I'm not going to do it with you. I want you to try it yourself and then send me the results. Grab a bottle of soda, bottle of Coke, Diet Coke works, whatever, and some Mentos. I know you guys have seen this at home. And I want you to see how many Mentos can go in the top of your bottle of soda and what happens. Now, I know you've all talked about it on TV or you've seen it on YouTube channels and you've seen them blast off. I can tell you, I tried this the other day with my daughter because all I had was canned soda. Her and her father went to the store and they bought a 12-pack of cans. I don't drink soda, they do. So they went out and they got a 12-pack of soda. And I'm like, I wonder if it'll work with a can. I didn't open the can of soda. I opened a can of soda and I poured it into a graduated cylinder. It didn't work. I was like, I wonder why it didn't work. You see it on TV all the time or on YouTube channels with them putting in the bottles of soda. So I was very perplexed as to why it did not work. My daughter was videoing. I put in the entire tube of Mentos into the graduated cylinder and it didn't work. So I wonder if it has something to do with the bottleneck of the soda and it being pressurized. I did not try it in the can, opening it up. I said, that might be something for my kids to do, my students to try. Maybe they can do something like that. I'm not sure. But graph your results for me. Record the data. Count how many Mentos you can put in and how big the reaction is. You can do a bar graph. Does it work? A yes/no bar graph. I know you've been working on that with your teachers. Try to do a bar graph. Set it up. Make sure you put your title on the top, Mentos experiment, on your x-axis and your y-axis on the side. X-axis is on the bottom, y-axis is on the side. Do a yes/no bar graph. How many Mentos? Did it work with 3 Mentos? Yes. Did it work with 2 Mentos? No. Track your data. See what happens. Now, for some of my younger friends, you can just count how many Mentos you had to put in and record it. Work on your counting skills. It's a great time. If you want to try this experiment and you have this stuff at home, it's a fun experiment to watch. Again, it's just yeast, hot water or warm water, hydrogen peroxide, and some dish soap. And have some fun with it. But remember, safety goggles first. Protect yourself. Wear clothing that you're not going to get messy. And if you make a mess, clean it up. It's not your parents' job. Have some fun with it. The bar graph example is in the link that your teachers are going to send out. The sorry, boys and girls. The questions are there as well. Have some fun. Enjoy yourself. Next week, we're going to start our life cycles. I have butterflies. Well, actually, caterpillars are coming to my house. So we're going to start life cycles. We're going to see if we can get some caterpillars to change into butterflies. They're on their way. Hopefully, they'll be here this week. And we will be watching butterflies change into caterpillars. I have my net. I have my house for the caterpillars. And we will be watching caterpillars change into butterflies. So get your life cycles, brains working. Remember how caterpillars change. what they need. And we will go on that journey starting next week. And then eventually, hopefully by the end of May, we'll be looking at rockets. I can't wait to see what's going to be happening, building some rockets, launching them, doing some moon phases, exploring space. Can't wait to see what's happening. I'll talk to you soon. Have a great week as always. Stay safe. Love you and miss you. Bye, boys and girls.